All right, for a question like this on the GMAT, it's a work rate question, but I use a concept that I invented called the flip-at-flip rule. I'm going to add to this video a link to another video I've done where I introduced the flip-at-flip. So I advise you watch that video first before you actually attempt this question. But using my flip-at-flip rule, this question talks about two pumps. So I'm going to look at the pumps as pumps A and B. Just going to do that very simply. And in this question, I'm going to assume that the A is going to be the faster one in this case, and B obviously will be the slower one. Now, you want to kind of think about something. There's a relationship between work rate and time, right? So if something has a faster rate, it has a lower time. So I'm going to actually make that statement here. If it is a faster rate, right? If the rate is faster, then the time it takes to do anything would be lower, right? So that's kind of like an assumption. You probably know that, but just want to say that out loud. All right, so based on that, this is where we are. Now, using my flip-at-flip rule, the A and B, what I established at the beginning, actually, let me go ahead and take this out a little bit. I'm going to move this information here. Just move it to the side. Now, if I establish in my flip-at-flip rule, when you watch the other video, you would see that whenever they give me, two pumps, the first thing I establish is the time for both of them, right? Now, in this case, we're not given the time. Actually, that's the question for A and B. We don't know the time. And then my flip-at-flip comes in. So flip-at-flip. Again, I really strongly advise you watch the video that I'm going to link to this video on the flip-at-flip, my introduction to flip-at-flip, so that all of what I'm saying here will make a little more sense. Now, this question tells us that combined, these two pumps can complete the task in 4 hours. So if you kind of think about it, their combined is 4 hours. But then the question tells us that the rate of A compared to B, again, we're considering A to be the faster one. A is the faster one. The A's rate is 1.5 the rate of B, of the other slower one. So I'm going to go ahead and do that here. I'm going to establish B as just a normal rate, but then A is 1.5 the rate of that. Now, you're probably thinking, why you put in the rate here? In my flip-at-flip concept, time is for my A and B, right? Time is here. But then the first flip is taking it from time into rate, because let's think about that for a second. If it takes you 2 hours to do something, right? That's your time, right? Take 2 hours. The rate at which you're doing it, if you're working at a constant pace, is a half every hour, right? You're doing a half of the job every hour. That's your rate. So essentially, to go from time to rate, you just flip it. That's where my flip here is coming from. So since they told us that the A, the first, I just established the first one as a faster one, that A is working at a 1.5 of the B. I'm making my 1.5 R here, and R being rate, and the B just has a regular rate. Now, at this stage, if you look at my flip-at-flip rule, everything at this stage should be flipped, right? Now, if we had been given the time, I would have flipped the time. Say we had given 2 hours or 3 hours, I would have flipped the 2 hours into 1/2 and the 3 hours into 1/3, right? But since they just told me the rate is already 1.5 the other, I'm just establishing that here. The one thing about the time here, though, this 4 hours, this is in time, right? And remember, at this stage, everything needs to be flipped. So this 4 needs to be 1/4. Now, that is a very critical mistake. I was actually working with a student earlier today, Duncan, and that was the mistake we made. I didn't change this 4 hours into 1/4. I just kept it 4. So you need to flip that. That's very important. At this next stage, it tells us to add. So I'm going to go ahead and do 1.5 R plus R, equal to 1. I'm just going to change the 1/4 to 0.25, right? Now, this is going to be 1.5 R plus R, which is like a 1 R. So if you add that up, you get 2.5 R equal to 0.25. And then you divide by 2.5, you divide by 2.5. Okay, this divides. So R is equal to, you want to get these to be non-decimal. So I'm going to move that 2 decimals here, top and top, and then do that at the bottom as well. So if you move 2 decimals at the top, you get 25. 2 decimals at the bottom, whatever you do to the top, you do to the bottom. You're going to get 250 because there will be an extra 0 there. Okay, so this is going to be 1 over 10, 25 into 25, 1 over 10. So I just found out at this stage, guys, that my R is 1 over 10. Now, the thing about that is, remember, the R are the rates, not the times. It's a very important distinction here. So essentially, I just found that the rate of B is really 1 over 10. And then, which means over here, if you think about 1.5 R, well, 1.5 is the same as 3 over 2, 1.5 is. So it's really 3 over 2 R. So I can say, really, this is going to be 3 over 2 times 10. Sorry, did I just do that? Times 1 over 10. Sorry. So 1.5 is 3 over 2. The R we just found out to be 1 over 10, right? From the calculation we just found here, right? Because I'm trying to work back towards the time, even though I have my flip, add, flip, this last flip is not really as important in this case because I'm trying to work back to the times I had originally, okay? And remember that in this first flip, I flipped whatever the time used to be here, which we do not know. Whatever this time used to be, I just flipped it to come to this level where I had 1.5 R and R. So essentially, now that I know that R is 1 over 10, and that this is 3 over 2 times 1 over 10, which is going to be 3 over 20. All I have to do to get the original numbers is just to flip it backwards, right? So 1 over 10 will now just be 10 hours, is what B did. And then 3 over 20, if you flip it back, becomes 20 over 3 hours. And when the question says here, it says, how many hours will it take for the faster pump, right, to fill the pool? As you could see, 20 over 3 is smaller. Smaller is a less amount of time compared to 10 hours. So it's the faster one because it took less time. And already we established it as a faster rate anyway. So the answer here is going to be E, 20 over 3, because when you flip the rates back to time, you get the 2 times, and you could tell obviously that the A is the faster rate but lower time. And that's exactly what they want. So this is a higher level work rate question. You definitely need to understand flip at flip and work rates so that when you watch this video, everything I said makes sense. Probably might not make sense the first time. Just watch it over and over again and it will add up. So that's how you answer this question. Pretty intense question, but this is how you do it. The answer is E.